Question 32. What was Bohr's objection to the Rutherford model of the atom? A. The electron could radiate energy and plunge into the nucleus. B. The electron did not follow elliptical orbits like planets around the sun. C. The space between the nucleus and the electron was empty space. D. In multi-electron atoms, the electrons could collide with each other. Okay, so we can see that throughout the history of physics, of science, a lot of scientists have tried to discover what is like the structure of the atom, right? So first Thomson had proposed an idea when he figured out about the electron that a atom is just like a sphere of uniform positive charge, and then we can also see that the electron was just like scattered around in that uniform positive charge, and it's just like the plum pudding, like like maybe not all of us will be familiar with the plum pudding because it's a traditional cake for his country, but we can imagine it's just like the watermelon model, like this little thing here is just like the electron, and then the whole thing here, the whole piece of the watermelon is just the positive charge. Makes sense, right? Or if you just think about the raisin cake, then each little thing here, the raisin, can be considered as a negative electron. Okay, so what happened when Rutherford in his lab, he tried to shoot an alpha particle, which later we know that that should be the helium nucleus, right? To be like 2 proton and then another 2 neutron that make it to have 4 nucleon in the nucleus, right? But here we have alpha, which is a positive charge, and then he shot it. Okay, we got an alpha particle emitter here, and then that alpha beam got shot into a gold foil. The thing is that what he see is that only the alpha get through the thin gold foil and then can be detected on the screen here, but also that at many other different direction, not just like straightforward through here, and especially there are some alpha detected at the front as well, which means that the alpha should hit something here that really hard at the center, like at the core, and then it even like got reflected back, So then that's why this model is proposed. There should be something in the middle of the atom, and that should be the nucleus. So with the Rutherford model, we got to know that okay, inside the atom there should be a little nucleus at the center, and then nucleus should be also positive because when alpha got hit, then it got reflected back, so it got pushed by something positive in the center, right? But then Rutherford models also like got something that cannot be solved yet, because in his model he assumed that we got the nucleus at the center, and then on the electron orbiting around the nucleus is planet around the sun. So then B is a correct answer. Okay, B is a true statement. And the thing is that we know that if some electron in motion, then it should radiate electromagnetic, it should radiate electromagnetic energy. If there's some electron that in motion, that in circular orbit, and if it got emitting radiate the energy, then later it should lose energy, right? And if it loses a lot of energy, then it doesn't have enough energy to keep rotating around the nucleus, and then in the end it should like plunge into the nucleus. That's why Bohr tries to explain, so what could be an enhancement to the model, and then he come up with the idea that each that electron should stay in some quantized orbit, because it should have a discrete amount of energy. A discrete amount of energy. It means that it is not like a continuous energy. It's just like discrete energy, some specific energy. And when the electron are in those quantized orbit, it doesn't emit energy, okay? It's only when the electron transition from an orbit into another orbit. So if it's going from a higher to a lower one, then it should emit a photon that have the same energy, like the gap between these one, okay? Or the other way, if some electron is located on this lower orbit and it got excited, when it receives some energy from a photon that shine on it, then it will get excited and then it will jump to another higher energy. So basically Bohr models try to explain this thing, which cannot be explained by the Rutherford model. And C is also an agreement between these two models, right? And it's also have been proven by this experiment. And in multiple electron could collide with each other. So that's not what Bohr's objection is about. So that should be A, okay? This is what Bohr objects to Rutherford model, and he would try to explain by his own model here. Sounds good? Okay, so whenever you come across this kind of question, just remember Thomson model is about like the pudding model, when you got all the charge distributed everywhere in a spherical atom. For the Rutherford, there should be a nucleus at the center, okay? And also like the electron will orbit around the nucleus just like planet around the sun, okay? There should be space between the nucleus and the electron. And for Bohr models, it should be like quantized orbit, okay? Discrete energy, and also like electron can get excited and move from a lower to a higher, or it can go from a higher to a lower energy state and then it will emit a photon of that same amount of energy. And here once again you can see this one look like a V, but it's not. It's something like this, okay? It's just like a ported. It's have a port in here and it's called like a nui, okay, which just stands for frequency. Okay, yeah, I wish that we should have a consistent symbol for the one as F, but sometimes it turns out to be more convenient to use this one in like later problems related to physics once you're familiar with them. Sounds good? Okay, so just distinguish between these three models of the atom. Good luck. Thank you.